I would like to show you today how to use dynamic simulation to create the cam profile. Let's open up an assembly. It consists of three parts. There's the housing, the valve, and the cam. Let's enter dynamics, and there's already constraints here so that when you enter dynamic simulation, the joints are already created. We have a revolution joint for the cam and a prismatic joint for the valve. And let's define some motion here. This cam, I want it to revolve, put in imposed motion, constant velocity of 360 degrees per second. Play it. That looks good. Now we need a spring for the valve. We can add a spring. Pick 2 points. Okay. Let's define the spring properties. You have to give it a stiffness. I'm just going to guess 15 newtons per millimeter. The free length, it needs to be longer for it to push the valve up to the cam lobe. I'll just say maybe 55, and I'm just going to highlight one of the digits and use my middle mouse wheel to adjust it. Let's just say the free length is 55, and I'll just put in a tiny bit of damping. Now, it doesn't look quite realistic yet, so these settings you can use to change just the appearance of the spring. So let's make a bigger radius here, and then you can adjust the number of turns, whatever you want, and the wire radius, you can increase it a little bit. I'm just going to say OK. And we got it. So if we simulate right now, that's good. It pushes the cam up to the valve, but we're getting penetration. So that's why we have to add a 2D contact between the cam lobe profile and the follower part of the valve. You can see that the joint triads, the triple arrowhead is the z-axis, and they're both pointing outwards from the profile, so that's what we want for the correct contact condition. You just say OK. Now let's play it. It looks realistic. But this initial position is not where we'd like it to be. Let's adjust that. I'm just going to play this simulation one more time. Now let's look at the position of this prismatic joint. You can see here it should be at 7.5. So at 7.5, that's kind of where we want it to start out. Back to construction mode, edit the prismatic joint, edit the initial position to be there we go, 7.5. Okay, now let's play it again. There we go, that's what we want. So now the cam is driving the position of this valve, and this is kind of the output of the valve position. Now we want to create an equivalent input, because we know what this valve motion should be. We need to create the correct cam profile. So we're going to use this information to create the input. So you can see here that at 0.33 is when we begin the rise part of the cam, and then the 0.5 is the peak, 18 millimeters, and the fall ends at 0.67. And just for convenience sake, I'm going to, instead of starting at 8 millimeter or 7.5, I'm just going to say set offset now, call it 0. Let's look at the output graph one more time, and you can see that the maximum lift is 10.5 millimeter. So now we have all the information we need to create the imposed motion of the valve. Now I'm kind of going to disassemble this whole simulation so that we're going to drive the position of the valve by the prismatic joint and not by the cam. What I'm going to do is I'm just going to in-place edit this cam, and I want to just kind of get this lobe out of the way here. There we go. Now we want to draw, I'll even turn off the imposed motion. Find the imposed motion, the position of this valve using the input grapher. And remember that we had 4 segments. One starting at about point, I'm just double clicking in the input grapher here, 1 at 0.33, and then the maximum lift is at 0.5. And I'll create another sector at 0.67, or here somewhere. Now let's define the second sector because it has the rise. Starts at 0.33 seconds. And it's going to be cubic ramp. Starts at 0, goes up to say 10 millimeter, 0.5 seconds. Now let's define the fall part. At 0.5 seconds it's at 10, but then at 0.67 it falls back to 0. Alright, so this got a little messed up here, so let's say it's supposed to be 0. This I forgot to put as a cubic ramp. And finally, stays at 0, the whole dwell portion, all the way to the end of 1 second. So there we go. That's what our input position is going to look like. Say OK. Now let's play it, see what it looks like. That's what we want. Now, we need a trace to use to define the profile of the cam. So we need to add a work point at the tip of the follower. And I'm going to use an x-axis and the intersection of this spherical face. Finish with that, back to BS, and let's create a trace at that work point. And I also want the trajectory to appear in the output grapher. Say OK. Now, play it. Look at the output grapher. The position. Oh, looks pretty decent. That's the shape we want. Now, how do we get that trace to look like the cam profile? What you have to do is just edit the trace and define the reference as the cam. And then the cam is rotating. So we're going to go back to the properties and enable this revolution, 1 revolution per second. And I'll play it again. Oh, I know what's wrong because I didn't turn off this 2D contact. So there we go. We are not driving this prismatic joint through this through the cam. I'll even turn off this motion. Okay, so back to once we have turn that motion back on. So once we have that trace that we like, we can export it as a sketch in this cam part. We'll do that, and just right click, export to sketch, and down here in the message it says select a component to create the trace sketch. So I want it to go in this cam component, click it, and you can see all these time steps all appear as points in a spline, and it's all connected together. So now we can in place edit this part and extrude the sketch we just created with DS. that looks about right. And it's not perfect. I didn't get that input curve just perfect. It's not, see some inflection here. Anyway, I just wanted to get the point across how to use, create the trace and the reference of the cam. So now let's go back to the beginning and we'll drive the position of this valve by the new cam profile. So what we'll have to do is turn off this imposed motion of the valve so that it gets driven by the cam again. Now let's edit this, unsuppress the 2D contact. Now let's edit what the profile is, because I don't want to keep using this old profile. I want to use the new profile. So let's use this profile, and let's see the triple arrowheads pointing out, which is what we want. Let's say OK. Let's play it. So I want to look at the position of the valve. There we go, that's the position of our valve now. I mean, we could tweak the input graph to make it look more like what we wanted, but the point is to use the trace, export to sketch, and that using that cam as the reference. So thank you for watching.